Modern research frameworks frequently and rapidly borrow the vocabulary of engineering, geometry, and physics to describe purely abstract concepts. Across papers in cognitive science, AI, and systems theory, we regularly see terms like latent space geometry, resonance, viability corridors, and tensegrity used to prop up entirely new theories. These words carry immense weight. When an author uses them, they make a specific epistemic promise to the reader that there are measurable variables, testable mechanisms, and mathematical precision underlying the text. In the hard sciences, that precision is the price of admission. Claims are backed by rigorous mathematical proofs and explicit falsification conditions. But in many modern frameworks, the operational content required to actually justify this authoritative language is completely absent. The technical vocabulary is present, but the mechanisms are missing. This specific epistemic gap between the authority of framework claims through its language and the actual substantiation it delivers is called structural debt. Using heavy structural vocabulary without providing structural mechanisms masquerades pure metaphor as engineering. It creates the illusion of scientific progress while delivering none of the load-bearing substance. To be clear, taking on structural debt is not inherently bad. It is a frequent and necessary byproduct of the scientific process. During early-stage work, researchers accumulate what is known as exploration debt. They use evocative, imprecise language to reorganize attention, clarify nascent ideas, and generate new hypotheses. Running a high balance of exploration debt is entirely acceptable, provided the authors accurately admit their work is at a low level of maturity. The hazard arises with representation debt. This occurs when a framework presents itself as highly mature and operational, yet fails to deliver the measurable variables to back those claims up. Much like technical debt in software engineering, where unaddressed code issues cause future fragility, unrepaid representation debt accumulates epistemic interest over time. That interest takes a heavy toll. Replication becomes harder, core terms grow increasingly ambiguous, and authors rely heavily on rhetorical defense rather than operational data. When interest on this debt goes unpaid, cumulative progress halts. The lack of operational grounding prevents others from building on or refuting the work, transforming research into an endless cycle of semantic debate that never produces a testable model. Representation debt does not happen by accident. Authors generate it through three distinct failure modes in how they frame their research. The first is vocabulary inflation. This happens when researchers deploy technical terms solely for their connotative force. They want the feeling of precision and mechanism without adhering to the literal meaning of the words. The second mode is operational deficit. Here, authors actually intend for their technical terms to be taken seriously, but they fail to define any measurable variables or specific update rules that would allow anyone to test them. The third is epistemic retreat. This is a defense mechanism. An author retains highly authoritative language in their abstract, but quietly downgrades their claims to subjective philosophy the moment someone demands falsifiable data. Together, these failure modes allow frameworks to survive peer review. They look exactly like engineering on paper, while retaining the ability to retreat into metaphor whenever challenged. Managing this epistemic gap requires an objective way to pin a framework's language to its actual deliverables. This is the operational accountability ladder, a 6-level taxonomy ranging from pure metaphor to deployed systems. At level 0 and level 1, the core obligations are simply internal coherence and logical consistency. Level 2, the conceptual model, represents the critical threshold. At this stage, authors must introduce operational vocabulary and clearly define their observable variables. Moving up to level 3, the scientific hypothesis, and level 4, the engineering framework, the obligations increase. These levels demand predictive claims, quantitative validation, and pre-committed falsifiers. Finally, level 5 is the deployed system. This apex requires proven real-world reliability and rigorous external adversarial costing. The latter forces both authors and peer reviewers to stop judging the aesthetic of the vocabulary and instead honestly align the words being used with the specific deliverables that have actually been completed. This matrix is the structural debt scoring rubric. It is a lightweight 10-point heuristic designed to grade operational claims and catch representation debt before publication. Let's look at how it works. Take example A. A framework claiming consciousness is a resonant attractor in a non-Euclidean manifold. The author notes this geometry can be verified strictly through subjective feeling. Running this through the rubric, we ask, are there quantities? No. Are there mechanisms specified? No. Pre-registered falsifiers? None. It scores zeros across the board, resulting in high representation debt. Now consider example C. This framework explores belief states using similar attractor models. However, it explicitly presents itself as a tentative Level 2 conceptual model, offering a preliminary, measurable tension metric accompanied by pilot data. Because example C defines its variables, sketches a mechanism, and accurately frames its maturity level, it scores in the 8 to 10 point range. The rubric strips away the illusion of complex vocabulary. It reveals immediately whether the underlying architecture is load-bearing or just a rhetorical facade. Structural vocabulary is a powerful tool for communicating complex ideas, but it carries an inherent epistemic cost that must eventually be paid. When researchers find themselves in debt, there are exactly two ways to close the gap. The first method is to execute the grueling operational work. Authors must define their variables, test their predictions, and move their substantiation up the accountability ladder to meet their language. The second method is adjusting the language downward. Researchers can simply acknowledge that their work remains at an earlier stage of maturity, relying on exploration rather than definitive proof. This establishes a definitive rule. The more technical the language a framework employs, the greater the absolute obligation to specify the exact conditions under which the framework would fail. Achieving a low representation debt score does not mean a theory is factually true. It simply means the claim is honestly positioned relative to its current evidence, and that honest positioning is the only way real cumulative progress actually happens.